Good morning, everyone. Today we're going to be looking again at the washer method, but this example involves rotating around the y-axis. So this is going to be example number 2 in our washer method series. What we're going to do is we're going to find the volume, created by revolving y equals x squared plus 1, y equals 0, x equals 0, and x equals 1 around the y-axis. So again, the key for me to understanding these questions is to get a good picture so you have a clear understanding of what it is that you're trying to rotate. So what we're going to do is we're going to start by drawing this graph. I might need some more room than that. Hang on, let me try again. Okay, so this is going to be our red function. Again, I know I'm not going very far. I'm only going between 0 and 1 on my x-axis. So I'm actually going to put in a couple numbers smaller than 1 when I do this. So of course I'm going to go ahead and plug in 0 for x. When I plug in 0 for x, I get 1 for y. Okay, so this is going to be 1. If I plug in 1 for y, plug in 1 for y, for x, plug in 1 for x, I'm going to get 2 for y. If I plug in a half for x, I get 1 1/4. Okay, and I know I'm only going from 0 to 1, so I'm only going to draw this half of the function. And I'm going to stop right there. I know that it's a parabola that continues, but it says right here I'm only going from 0 to 1. So if I come over here, I'm going to go ahead and put these two functions on my graph. Use the green for that. This and this are going to tell me that I have to stop here, and I have to stop here. Okay, again, this is 1, this is a half. So I'm going from x equals 0 to 1. And we are supposed to be rotating around the y-axis. So we're going to go in this direction with this graph. Now, we can see that what we're going to be rotating is this shape down here. So what's going to happen is it's going to come over here, and it's going to give us a mirror image on this side. And essentially we're going to get something that when we rotate it is creating a shape like this. Okay, so it's kind of like it got a bowl shape scooped out of the middle here. And so what I want you to see is that when we rotate the bottom part from here down, there is no hole in this part. When it's rotating around over here, this part at the bottom is not going to have any hole in it at all. So that has to be treated as a different integration than the part at the top where there is a hole. Okay, so this bottom part from here to here is a disk. But the top part up here, we can clearly see that when we rotate this, we've got a hole in the middle. So this top half is a washer method. So we're going to have to use two methods to get this answer. Okay, so if we start with the disk part, because I think that's the one that's a little bit maybe easier for us to see, and we're going to add these two areas together. and that'll give us the total volume. So for our disk, we're going to have pi, and we have to use y numbers because we are rotating around the y-axis. So let's look at where this goes. Our bottom part is going from y equals 0 to y equals 1. And what is the radius that we're using for this disk? Well, look at your picture, because it's not a function with x's or y's in it this time. Look at our picture. Our radius goes from the y-axis over to where we're stopping. It goes to this green line. What is every single radius in this bottom area is the same? What is that radius? It's a radius of 1, because we were going between x equals 0 and x equals 1. dy, because we're rotating around the y-axis. Okay? Plus, we're going to have another integral for our washer method. Okay, so let's come up here and look at our washers. On our washers, we have two different functions we need to think about. We need to think about the outside, going from the y-axis all the way to the outside of the shape. Okay, so that blue line is my r of x, my outer radius. Okay, and what do you know about the outer radius? No matter where we draw it from in this upper part, what do you know about the outer radius? Well, it's always going over here to this green line. And where is that green line? That green line is at 1. Minus the inner radius. Okay, well, what's my inner radius here? My inner radius is going to go from the y-axis, because that's where I'm rotating, to the function that's creating the hole. And the function that's creating the hole is right there. What function did I land on that's creating the hole? That's the inner radius. And that function is y equals x squared plus 1. But my problem is I have to have an equation here in terms of y. So before I can use this, I have to go ahead and solve for x. Okay, so the function that's going to go here is y minus 1 squared dy, because again we're going around the y-axis, and we have to look at our picture. What y values are we going in between here? Well, we're going from 1 to 2. And so now all we have to do is take those antiderivatives to get our answer. So I'm going to go ahead and pause here. You go ahead and calculate the answer, and then I'll show you my work. Okay, so hopefully you can see that all I've done so far is to simplify. This function was pretty simple, but over here I had to do a little bit more simplifying, so I tried to show all my steps so that no one would get confused about how we were simplifying. Okay, so once you've made sure that this is the function that you're simplifying to, then you can go ahead and take your antiderivative. So go ahead and take your antiderivative, pause, and we'll see what you get. Okay, so if you take the antiderivative of those two functions, you should get something that looks like this. And once you've made sure that that's what you are evaluating, go ahead and pause and evaluate those functions. Okay, so hopefully you went ahead and evaluated that, and when we evaluate this very carefully, we end up with an answer of 3 pi over 2. So what that gives us is the volume of the solid. Okay, this kind of rectangle shaped bottom with the bowl carved out of it. And that's our volume. Please let me know if you have any questions.